All right, this lesson is on sample space, and this has to do with probability. So when you're calculating probabilities, one of the things you need to know is how many possible outcomes there are. So what sample space is it's just a list of those possible outcomes. So the sample space describes all of the possible outcomes of an event. If I can get my pen to write here. So all of the possible outcomes of an event. Now, the sample space can be displayed in any of these different ways. So it can be displayed with lists, with tables, or with tree diagrams. And the reason we want this is so that we can help to determine the probability of simple or compound events. So when you're calculating probability, it's important that you understand how many possible outcomes there are and also what those possible outcomes are. And the sample space is just a list of those. All right, so here's an example. The New England Patriots and the Dallas Cowboys are playing. What are the possible outcomes of the game? So I could simply say the Patriots win. That's one potential outcome. Another potential outcome would be that the Cowboys win. So there's two potential outcomes. I don't know why I wrote game there. I meant to write win. Cowboys win. Sorry. Now, you could be thinking, well, isn't an outcome that the Patriots lose and the Cowboys win? Yeah, so Patriots lose is the same thing as Cowboys win. And we're assuming that a game can't end in a tie here, okay? Number two, a number cube is rolled. What are the possible outcomes? So there's 6 numbers on a number cube, so there's 6 different outcomes. And so what are those outcomes? Well, they're either 1, 2, 3, 4, 5, or 6. Those are the possible outcomes. Okay, so it's really a pretty simple concept. So let's look at some other examples here. So we're going to write these in either a list or a table. So for breakfast, Jamie can choose from cereal, eggs, or a muffin. So she gets to pick one of those. And then she can also drink coffee, orange juice, or milk. So she can pick one from here and one from here. So what are the possible outcomes? So we're going to write these as a list. So her first choice is cereal, eggs, or muffin. Okay, so she could choose cereal, and then she can choose either coffee, orange juice, or milk. So cereal and coffee, that's one choice. Another choice would be cereal and OJ. Another choice would be cereal and milk. So those are the 3 choices that involve cereal. And then basically we're just going to repeat this for eggs and a muffin. Okay, so you've got eggs and coffee. You've got eggs and OJ. And you've got eggs and milk. And then lastly, we're just going to repeat this, but now with the muffin. So you've got the muffin and coffee. So again, what we're writing here is the sample space. It's a list of all the different outcomes. Muffin and OJ. And then the last one, muffin and milk. All right. So the next piece here just said, how many possible outcomes are there? All right. So 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 possible outcomes. Now there's a shortcut way that you can figure out this 9. It's pretty cool. It's called the fundamental counting principle. If you look at how many choices there are for the first thing, coffee, orange juice, milk, there's 3 choices. And how many choices there are for the second thing, cereal, eggs, and a muffin, that's 3 choices. So if you take those numbers of choices for each thing and multiply those together, it gives you the total number of possible outcomes, which is 9. All right, at registration, a student can select from Spanish or German class, as well as art, music, or theater. What are all the possible outcomes? How many total outcomes are possible? Okay, so the same idea. So you've got Spanish, and then you can choose art, music, or theater. So we'll do Spanish and art, and then we'll do Spanish and music, and then Spanish and theater. Spanish and music, Spanish and theater. And then we're just going to repeat this with German. So if you chose German, then you still have those other 3 choices of art, music, or theater. So German and art, German, German, and music. And then last, German and theater. All right, so that's all of our possible outcomes. And you can count, there's 1, 2, 3, 4, 5, 6. There's 6 possible outcomes. But look, we can use that fundamental counting principle. There's 2 choices of Spanish or German, and then there's 3 choices of art, music, or theater. So if we take 2 times 3, we get 6. Again, that's the fundamental counting principle. All right, so now I'm going to introduce what's called a tree diagram. So a fair coin, that just means that it's balanced, it's not like a trick coin, is tossed 3 times. What are all the possible outcomes? So we're looking at what are all the things. So the first time that you flip it, it could land on heads or it could land on tails, right? So now the second time you flip it, so let's say it landed on heads the first time. So now for the second flip, it could land on heads or tails again. And the same thing, if it landed on tails the first time, for the second time it could be heads or tails. And then we're going to flip it one more time. And so if you look at this branch, this is why this is called a tree diagram. So this is saying the first time I flipped it, it landed on heads. The second time it landed on heads. And now the third time I flip it, it could land on heads or tails. This is showing first time heads, second time tails, and then the third time could be heads or tails. And then we just do the same thing down here. And again, I'll explain this a little bit better on how you read this. Just one second, let me write this down. So if you follow the branches will tell you the sample space. So for instance, if I followed this branch right here, this branch says that I got heads, heads, heads. This branch, heads, heads, tails, that's another possible outcome. And then I have heads, tails, heads. I'm just following the branches to get my sample space. So heads, tails, heads. And then this branch is heads, tails, 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 tails. And this is tails, heads, heads. Again, just following the branches. Heads, heads. This is tails, then heads, then tails. Tails, then heads, then tails. Tails, tails, heads. Tails, tails, heads. And then the last one here is tails, tails, tails. So a tree diagram for something like this is a really easy way to come up with the sample space. And so you can see how many outcomes there are. There's 1, 2, 3, 4, 5, 6, 7, 8. There's 8 possible outcomes. Well, we can still use the fundamental counting principle. The first time I flip the coin, there's 2 possible outcomes. The second time I flip the coin, there's 2 possible outcomes. And the third time I flip the coin, there's 2 possible outcomes. And I don't know why. So what we end up with here is 2 times 2 times 2, which is 8 possible outcomes. All right, so here they want us to create a list. So it says Amanda will roll a number cube, and flip a coin. If Amanda rolls the number cube once and flips the coin once, then what are the possible outcomes in which the number cube lands on an odd number? So we're only looking at odd numbers. Okay, so one possible outcome is the number cube lands on 1 and the coin lands on heads. Another one would be it lands on 1 and the coin lands on tails. And we have 3 in heads and 3 in tails. Now, how come I didn't list 2 here? That's because it said odd numbers. So the number cube lands on an odd number. That's the only ones we're interested in. And so then we have 5 heads and 5 tails. All right, so that's the sample space for that situation. And you can see there's 6 possible outcomes. So how many ways are there to get an odd number on a number cube? There's 3, and then a coin has 2 possible outcomes. So 3 times 2 is 6. All right, the 2 spinners below are spun at the same time. What are the possible outcomes of the 2 spins? All right, so if this lands on 1, then you could have 1, and this one could be, I'm going to just put Y for yellow and R for red and O for orange and B for blue. So you could have 1 in yellow, 1 in red, 1 in orange, 1 in blue. And then we could have the same situation with the number 2. So the 2 could be yellow, 2 in red, 2 in orange, 2 in blue. All right, 2 possible outcomes here. 4 here. 2 times 4 tells me there's 8 possible outcomes. 1, 2, 3, 4, 5, 6, 7, 8. All right, so here they want us to create a tree diagram. So a clothing line has shirts in red, blue, or white, and pants in gray or khaki. How many different combinations can be made with the clothing line? And they want us to make a tree diagram to do this. All right, so for the shirts, I have red, blue, or white. I'm going to abbreviate it like this: red, blue, and white. And in this tree diagram, I'm going to have it go down instead of across. That's totally fine. All right, and then the pants can be gray or khaki. So if I have a red shirt, then I have a choice of gray or khaki. If I have a blue shirt, I still have the same choice of pants, gray or khaki, and the same thing here, gray or khaki. So if you follow the branches here, you could have a red shirt, gray pants, red shirt, khaki pants, blue shirt, gray pants, blue shirt, khaki, and so on. And so it wants to know how many different combinations there are. So there's 3 choices for the pants, no, for the shirt, sorry, and 2 for the pants. So 3 times 2 is 6. And you'll see there's 6 branches here. 1, 2, 3, 4, 5, 6. All right, when buying a car, Esther can choose a 2-door or a 4-door with leather or cloth interiors in black, silver, or white. How many different combinations can be made with the car options? All right, so we got 3 different things going on here. So the first one is she can choose a 2-door or a 4-door car. Okay, so 2 or 4. Then she can choose leather or cloth. Okay, so let's split these out. We've got leather and cloth, leather and cloth. And then she can choose black, silver, or white. So there's going to be 3 branches off of here. 1, 2, 3. 1, 2, 3. 1, 2, 3. Black, silver, or white. So I'll just put B, S, W, B, S, W, B, S, W, B, S, W. And So if you follow the branches, you could have a two-door with leather with black interior, two-door leather with silver, two-door leather with white, two-door cloth with black, two-door cloth with silver, two-door cloth with white. And so if you follow the branches here, there's one, there's two, there's three. So it's 3, 6, 9, 12 possible outcomes. But we can also still use the fundamental counting principle. So for the first thing, two-door or four-door, you have two choices. Leather or cloth, that's two choices. And then for the color of the interior, black, silver, white, there's three choices. So if we do 2 times 2 times 3, we get 12 possible outcomes. All right, I think this is the last example I have for you. Sergio tossed a two-sided red and yellow counter chip. I don't know what that counter chip is, but it's just a chip that one side's red, one side's yellow. Create a tree diagram to represent all of the possible outcomes for the coin landing on red or on yellow. Tossed a two-sided, but represent all the possible outcomes on red or yellow. So what's missing here in the description is that Sergio flips it 3 times. All right. So the first time he flips it, it could land on red. So I'm going to do this tree diagram a little bit different here. Or it could land on yellow. Then the second time, we've got red or yellow again. So red or yellow. And then the third time, you've got red or yellow. Red or yellow. All right, so again, remember, you just follow the branches. So one possible outcome is red, 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 yellow, red, yellow, red, red, yellow, yellow. All right, and so the first time, so if you want to figure out how many different outcomes there are, the first time you do it, there's 2 possible outcomes. The second time you do it, there's 2 possible outcomes. And the third time, there's 2 possible outcomes. And again, I wrote 3. I don't know why I did that. Something else going on in my brain, I guess. So 2 times 2 times 2 is 8 possible outcomes. All right, so that's sample space. Again, it's just a list of all the possible outcomes, and this shows you different ways that you can come up with that list. So I hope this was helpful. If so, give it a like and a subscribe, and feel free to leave me a comment. Until next time.